This is actually the sort of question you could do without being given the graph. I like it. I've never really thought about this function before. So y equals log to base x of 2. Just going to move the graphs for a second, come down here. Well, we can rearrange that. It's a little bit easier in exponential form, I think, to get answers. So x to the y equals 2. Then I'm just going to choose some different values of x and the final value of y. So if x, for example, was 2, then 2 to the power of 1 is 2. If x is equal to 4, then it's 4 square rooted, which is 2, so it's going to be a half. And we can kind of see a little pattern emerging. It's going to be the cube root of 8. It's going to be the 4th root of 16. If I think about, for example, if x was equal to 1, then I couldn't actually get an answer. But if I went with 1.0001, then y would have to be really, really big. So that would end up being infinity, kind of. And that can get me, it's not gonna, okay, it's gonna approach infinity. That's what I'm trying to say. And this is enough. In fact, it's always going to be positive. We're going to have a line at 1 where there's an asymptote. Because I think we were told actually that x was greater than 1. We won't think about negatives here. But it's going to be coming down from infinity. And then when x is equal to 2, it equals 1. Let's just put a point there. And then when x is 8, oh, sorry, 4, we get a half. So I'm kind of doubling it here. And then 8, it's going to be sort of over here. We've got a third. And you can see this smooth curve forming. Looks a little bit like the reciprocal function. Of course, it's not. And that is going to be our graph. And from that, we can see the answer is E.